Hi, Assalamualaikum. Today we are going to continue from the vector, which is specifically today for the dot product. Suppose we have two vectors A and B here. So if we want to find the dot product between these two vectors, then we'll just need to multiply, right? A dot B will be x1 multiplied with x2 plus y1 multiplied with y2 plus z1 multiplied with z2. So this is the dot product for these two vectors. So we define the dot product, then we also know that the dot product is sometimes known as the scalar product, because when we multiply the components here, then we add them, so we'll get a number. So this is actually a scalar because we'll get a constant number, or sometimes called inner product. Inner product is actually the dot product. Why? Because we multiply the inner component here, right? x1 with x2, y1 with y2, and z1 with z2. Alright, let's see how to find the dot product between two vectors. Suppose we have two vectors here. So we know that this is for the first vector and this one is for the second vector. What we need to find is actually the dot product between these two vectors by multiplying the first component. So 2 with 1. Alright, 2 with 1. The second one, -3. Do we have the second component in the second vector? No, we don't have. So -3 multiplied with 0, and the last part +4 multiplied with -2. So we will have something like this. Alright, so now why we have -3 multiplied with 0? Because we don't have j component here. Right, now when we multiply this and we add them together, we get -6. So -6 is a constant, it's a scalar, so that's why it is known as scalar product. Let's see another example. Suppose we have two vectors with its components in this form. Now we can multiply 5 with 3, 1 with 2, and -2 with -1. We add them together, so we will get 19 as the inner product or the dot product. Now let's see some algebraic properties of dot product. Suppose A, B, and C are vectors and K is the scalar. Then we have the first property, which is when we we find the dot product between the same vectors, which is A dot with A, will get the magnitude of A square. Second one, we find the dot product between A and B is actually the same as the dot product of B and A. This third one is actually the distributive law here. So the dot A and B plus with the dot of A and C. And then if we have a scalar multiplied with A, alright, scalar multiplied with A, you'd find the dot with B, and then we can also write K in front here, and you find the dot product between A and B. Or you can write vector A dot with the the K vector B. Alright, now if you have zero vectors, and then you find the dot product with A, then you will get a 0. Alright, now we have a theorem. If the angle between two vectors, suppose we have vector A and B, is theta, then we have that A dot B will be equal to the magnitude of A multiplied with magnitude of B multiplied with the cos theta. So magnitude of A, magnitude of B, cos theta. You have to remember this theorem. Alright, so this is important equation here. We can rewrite this equation to write cos theta as the subject. Therefore we got cos theta, which is equal to A dot B divided by the magnitude of A, magnitude of B. Alright, so we are done with this one. Now suppose we have this example. We are given with the magnitude of A is 3 and magnitude of B is 6. The angle between A and B is given as 45. So we need to find the dot product between A and B. If we are given with the length of A and length of B and also the angle between A and B, we can find it using this formula. You just need to plug in this one as 3, this one as 6, and this one as cos 45, something like this. Alright, so now you just need to plug in into the formula. You get the dot product between A and B. So do you remember how to find the cos of 45 or cos pi over 4? So for the 45 degrees, you just need to draw the triangle 1 and 1. So this is the triangle. So of course this is 45 or pi over 4. This one also pi over 4. So of course by Pythagoras theorem, this one is square root 2. So to find the cos is actually, let's say this one is the angle, right? So the cos is just adjacent over hypotenuse. So this one will be 1 over square root 2. That's why we have this one 1 over square root 2. Now we simplify this one and finally we got 3 root 3. All right. Now we need to find the angle between two vectors A and B here, where A is given by this vector and B is in this form. So to find the angle, again, we need to use the formula given by the dot product, which is equal to this. All right. So initially we have A dot B equal to magnitude of A, magnitude of B, cos theta. But now we make cos theta as the subject because we need to find theta later on. So we have to find the dot product between A and B. We have to find the magnitude of A. We have to find the magnitude of B. So we firstly find the dot product between A and B. So we will get this one. How do I get this one? So 1 multiplied with 4, right? Sorry, 1 multiplied with 4. 2 multiplied with 0 because we don't have the second component in B vector. And negative 3 multiplied with negative 1. Alright, so that's why we have 6 here. Now we have to find the magnitude of A. How to find the magnitude of A? We have to use the formula for the magnitude, which is the square root of the square root of the addition of squares of each component, right? So we have this one, right? You square 1, 2, and negative 2, and you get this one. So for the magnitude of B, you just need to square 4 and negative 1 here. You add them together, so we'll have square root 17. Plugging into this formula, 6, 3 and square root 17. Therefore we have cos theta, which is given by this. Simplify this 6 and 3, we'll get 2 over square root 17. But this is cos theta. We need to find the angle. To find the angle, meaning to say that we need to find the theta. How do I find the theta? You need to find the cosine inverse. So the cos inverse of 2 over square root 17. Therefore theta we will have as 1.0644 radian by using the calculator. Please make sure that your calculator is in radian. If you want to write your calculator in degrees, then please set your calculator in degrees. Alright, now we need to see the concept of orthogonal vectors. So what is orthogonality? Suppose we have vector A and vector B. So vector A and B are orthogonal if they have the 90 degrees there. So we have the vectors A and B are orthogonal where if and only if, this one is the symbol for if and only if, A dot B will be equal to 0. Why? Because initially we have A dot B is equal to magnitude of A multiplied with magnitude of B cos of theta. But since A and B are orthogonal, so this is 90 degrees. So you will have to find the magnitude of A, magnitude of B cos of 90 degrees. Pressing your calculator, this part will become 0. So A, magnitude of A, magnitude of B multiplied with 0. So you get 0. So that's why we have A dot B will be equal to 0. So now let's see this example. Given these two vectors, we need to determine if A and B are perpendicular, sometimes known as orthogonal, sometimes known as perpendicular. So we need to check whether A dot B is it equal to 0. So if A and B are perpendicular, if and only if, then this one will have A dot B equal to 0. So we need to find the dot product between A and B here. So to find the dot product between these two vectors, you just need to multiply negative 1 with 3 plus 2 with 4 plus 5 with negative 1. That's why we have this equation here. So we simplify this, we'll get 0. A dot B is equal to 0. What can we say? So we can say that if A dot B is equal to 0, then A and B are perpendicular or orthogonal, because this is if and only if. It goes this way and also it goes this way. Alright, now we can say that A and B are perpendicular. We can make some remarks here. Suppose we already have a dot, the dot product is given by this formula. Suppose A and B are in the same direction, then A dot B is equal to magnitude of A multiplied with magnitude of B. Why? Because when we have A and B in the same direction, meaning to say that the theta, the angle between these two vectors, is 0. So when you plug in cos 0 here, cos 0 is actually 1, so magnitude of A multiplied with magnitude of B multiplied with magnitude of 1, so we just have that part. Alright, so now if A and B are in the opposite direction, then we will have this equation. Why do we have this? Let's see this one. Suppose A in this direction and B in this direction, they are in opposite directions, so the theta, the angle between these two vectors, is actually pi. When we have the formula A dot B equal to magnitude of A magnitude of B cos of pi, cos of pi is actually -1. That's why we have this formula. Alright, now let's see the concept of directional angles and directional cosines. The directional angles are angles that are made by the vector with the x-axis, y-axis and z-axis. Suppose we have this point here, A1, A2, A3. At this point, the coordinate for this point is given by that. Now we find the vector, so which goes that way to that point, so that is a vector. So we know that the vector for A can be written in this component form. Alright, so now the angle between this vector and x-axis is actually represented by this alpha, which has the relation cos alpha, which is equal to A1, the first component, divided by the magnitude of A. Let's see the angle that is made by the vector with the y-axis, meaning to say that we have this beta angle. So we have the relation that cos beta, which is equal to the second component divided by the magnitude of A. And the last one, we have the angle that is made by the vector with the z-axis. So we have this one gamma. So cos of gamma, which is equal to the third component divided by the magnitude of A. And if we square cos alpha, cos beta, cos gamma and add them together, we will get 1. Alright, so if the question asks you to find the directional cosine, meaning to say that you have to find cos alpha, cos beta, cos gamma. But if the question asks you to find the directional angles, you just need to find the cos inverse here, meaning to say you have to find alpha, beta and gamma by taking the cos inverse to the right side of the equation. Now we have cos alpha given by this, cos beta given by this, and cos gamma given by this equation. We can rewrite this equation so that we want to make A1, A2 and A3 as the subject. Therefore we have A1, which is given by this equation, A2 given by this equation, and A3 given by this equation. We know that the vector A is written as the component form here, since A1 is actually this one, A2 actually this one, and A3 actually this one. So we substitute that equation into this formula. We have these vectors. Because we know that this modulus A, which is the magnitude of A, is a scalar, we can take it out from the vector. So we factorize something like this. Then we can write that A, we can bring this, what do we call, A over magnitude of A, which is given by this equation. So 1 over magnitude of A multiplied with the vector A, we actually have the vector with the components cos alpha, cos beta and cos gamma. Now let's see example 5 here. We need to find the directional cosines and directional angles of this vector. So we start with cos alpha, cos beta and cos gamma. So let's do one by one. Let's say we start with cos alpha. So the first component, this is A1, which is equal to 1, A2, which is equal to -2, and A3 which is equal to -3. So you just need to plug in into this formula, but you have to find the magnitude of A here. So firstly, we find the magnitude of A, which is equal to square root 14 here. So now you just need to substitute inside this formula. A1 is actually 1 divided by square root 14. So this is cos alpha. Then we can find, alright, this is the directional cosine. We want to find the angles, therefore alpha is the cos inverse of this value. So we press your calculator, you get 1.3 radian. Now let's do for the cos beta. We know that A2 is actually -2 and modulus of A is actually 14. Therefore we substitute inside this formula, we got -2 over square root 14. So to find beta, therefore we have this cos inverse of -2 over square root 14. So we get beta, which is equal to 2.13 radian using your calculator. And the last one, we have the cos of gamma. So A3 is actually -3 and the magnitude of A is actually this square root 14. So we substitute inside the formula, we get -3 over square root 14. To find the gamma, we have to find the cosine inverse of this value. Then we have this equation, and using your calculator you get 2.5 radian. Alright, so it's up to you. If the question asks you to write your angles in radian, then you write the equation in radian. Please make sure that your calculator is set in radian. Alright, and the last part for this video, we need to see the projection of vectors. Vector projection of B onto A, alright, can be represented by this. Suppose we have the vector PR here and another vector which is PQ, and we can represent the vector PR as A and vector B as PQ. Right? If we want to find the projection of B onto A, meaning to say that this is B and this is A, we want to project B onto A, we need to bring this, what we call vector to this vector. Alright, so how do I do that? Alright, so we start by having this, what we call dotted line. So this is labeled as point S, suppose. So we have a vector which is PS. So that PS here is actually the vector projection of B onto A. Alright, so PS here, this one. Okay, can you see that? Alright, it's the vector projection because P falls onto A, so B onto A. This vector projection of B onto A can be written as projection of B onto A, which is given by this formula. Right? You just need to find, you just need to remember this formula and plug it into the formula with the values, then you get the answer. Now we have another projection which is the scalar projection. Basically this is the same diagram as this one. Alright, so we just need to find the scalar projection, meaning to say that we need to find this length here. So this is known as scalar projection of B onto A. Just now we find the vector, but now we just need to find the length from P to S. That's why it's known as scalar projection. So now it's sometimes known as component of B along A, sometimes known as component of B along A. So this can be written as component of B along A, which is given by this equation. So let's see how to use this formula. For example 6, which is the last example in this video, we need to find the scalar and vector projection of B onto A. We are given with two vectors here. So let's say we want to find the scalar projection first. So this scalar projection is actually the component of B along A, which is given by this formula. So we see that, okay, we need to find the dot product of A and B, and we find the magnitude of A. Therefore we have this dot product and we find the magnitude of A, which is given by square root 21. We just need to plug it into this formula, therefore we get 1 over square root 21. Now we want to find the vector projection of B onto A. Alright, so projection of B onto A, which is given by this formula. So we already have the dot product, and we already have the magnitude of A, and we also have the vector A because it is a vector. All right, so now we just need to plug in this into the formula 1 over square root 21 square, and this part is actually the vector A given here. So you just need to simplify this. You get 1 over 21 of vector A, and you need to multiply this, which is a scalar multiplication. So scalar multiplication meaning to say that you can multiply with each component of this vector. So you simplify, you get this vector. So this is the last answer for this one. You see that for the component of B along A, which is the scalar projection, you get a scalar, which is a constant number. But for the vector projection, which is the projection of B onto A, you see that it's actually a vector. So that's it. Thank you for watching this video. In the next video, we will learn on the vector product or the cross product.